This video goes over 6.7, which is the fundamental theorem of calculus. Ha ha, 6.7. No memes. You guys are gonna kill me with that one. This is kind of a shorter lesson, but it does lead into the next few. So let's take a look at what's going on. So just to review, when you have the integral notation, what this means is the area under the curve bounded by the function and the x-axis, starting at 2 and going to, starting at 0 and going to 2. As you can see here, the area under the curve from 0 to 2 of the function. Now, we have done many different ways of approximating area. We've used Riemann sums, and again, you could also use trapezoidal or midpoint, but Riemann sums use the left or right endpoint of rectangles. This is kind of appropriate to do when you have a table. We've also looked at geometric representations where if you look under the curve, if they're basic shapes that you can find the area of, you can just calculate the shape, each shape under the curve, and that's usually appropriate when you have a graph. And the last method is integration. This is the formal way. This gives you an exact area, and we do this when we have an equation. So if we go back to the fundamental theorem of calculus, basically, if you have an integral from a to b, or if you're trying to find the area under the curve from a to b of the derivative function, the fundamental theorem of calculus tells you that you can cancel out the derivative because integrals and derivatives are opposites of each other. That's why they call the integral the antiderivative. But basically, if you perform this operation, the integral and the derivative cancel, and you just plug in b to the function and then subtract it from a. So notice how these are lowercase, because these are our original functions, because we're taking the integral of the derivative. Now, if you go to the one below it, notice how this is just the area under the curve of the function, and then we use capital letters to indicate that it's the area function, or the area under the curve. Right, so these examples, if you take a look, you're basically just taking the integral of a derivative or the integral of the function and finding the area. So here, if you look at example 1a, we're trying to take the integral of the derivative. So basically, this is going to just be g of 5. Again, we plug in the 5, the integral and the derivative cancel, and we subtract that from g of 1. Part B. So first off, our boundaries are switched. So let's change them and put a negative outside. So this would be negative 2 to 5, h double prime of x. This is a double prime, so think of this. This is h prime of x, and then prime again. Think of it like that. So the integral is going to cancel out this prime, and I'm left with the single derivative. So this will be h prime of 5 minus h prime of negative 2. And again, because this is two derivatives, so the integral undoes one of them. So I'm just left with one derivative. And if I wanted to simplify this, I would distribute the negative, and I would just say this is h prime of negative 2 minus h prime of 5. All right, example 2. We're going to do the same thing. We're just going to use the table to actually find the values. So looking at A, the integral is going to cancel out with the derivative. So this is just going to be f of 6 minus f of 1. And if we look at our tables, f of 6 is negative 3, f of 1 is 2, which gives me negative 5. Part B, we are going to pull the constant outside, and we are going to switch our boundaries. So we're going to make it negative 2, the integral from 3 to 13 of f prime of x dx. So again, the integral cancels out with the prime. So this is just going to be negative 2, and it's going to be f of 13 minus f of 3. F of 13 is 10, f of 3 is 7. So this is going to give me 10 minus 7, which is 3, times negative 2, which gives me an answer of negative 6. Part C, we do have this constant outside. If you recall from the previous lesson about your derivative rules, you can pull the constant outside, subtract the boundaries, and then just do the integral as normal. This, since we are taking the integral of the original function, this is going to be, we're going to use capital F when we write f of 7 minus f of 6. And again, this is the area under the curve. So this is the antiderivative or the integral. And this value is just going to be negative 2 times 1. Now, f of 7 is negative 7. And then f of 6 is negative 2. I take that back. F of 7 is going to be 5 minus f of 6, which is negative 2. So this is just going to leave me with 5 at the very end. Now, we can switch the boundaries if we want. It's not necessary, though. It's really necessary when you're doing a graph. But I guess I can show you both ways. But from here, we're going to take the integral of the double derivative. So again, the integral is going to cancel out with one derivative. And I'm going to be left with f prime of 1 subtract f prime of 7. Now, f prime of 1 is going to give me 8. F prime of 7 gives me negative 3. And this is going to give me 11 at the end of the day. Now, again, if you realize if I switch these, it would be negative from 1 to 7. And that would give me negative f prime of 7 minus f prime of 1. F prime of 7 was negative 3 minus 8. And again, this is negative 11, but then that negative makes it positive. So we end up with the same answer. Okay, so we're going to pull the constant outside. That's going to be 3. And then we're going to take the boundaries of it. So this is going to be 30 plus the integral from 3 to 13 of f prime of x dx. And so we have the integral of a single derivative. So those are going to cancel out. And we're going to be left with f of 13 minus f of 3. Now, f of 13 is going to be 10. F of 3 is 7. And so this is going to be 3 plus 30, which gives me 33. Last question. Let's pull out the negative 2 outside the integral. And again, remember, you can switch these and then make that positive. But again, it's not necessary. It's only really necessary when you're doing the graph. So this is the integral of the function f. So this is going to be a capital F because it's the area under the curve. Plug in 3. Subtract capital F of 6. Going up to our table, capital F of 3 is 6, and capital F of 6 is minus 2. So this is going to give me 8 times negative 2, which equals negative 16. Okay, our last example. So we're going to just do this with graphical representation. So 3a, once you take the integral of a derivative, those cancel out. So this is just going to be g of 3, subtract g of negative 1. And so the function at 3 is going to be 1 minus, and the function at -1 is going to be 3. So this all equals -2. So moving on to part B. Now we do need to switch these boundaries around, make it negative. Now what does this mean? This means take the area under the curve from 1 to 6 of g of x. So the area from 1 to 6 gives us this rectangle in yellow and this trapezoid in orange. So the rectangle is going to be 1 times 4 for the area plus the trapezoid is going to be base 1, which is 1, plus base 2, which is 3, times the height, which is 2, all divided by 2. And so simplifying this is going to give me 4. And this will also give me 4 because the 2's cancel. 1 plus 3 is 4. So it's going to be 4 plus 4, which is 8. But we do have the negative outside. So we do get -8. And I may have made a slight mistake. The base here is 3. 1, 2, 3. So this should technically be -7 instead. Part C, we do have a couple properties that we need to use. So we do have a constant outside the integral, so we're going to pull that out and then multiply it by the difference of the boundaries. Now again, this is a integral and this is a double derivative, so the integral is going to cancel out with one of the derivatives. So if we simplify, that gives me 4, because it's 4 times 1, plus this is going to be g prime of 6 minus g prime of 5. And so this is the slope of the tangent line at 6. If I come up here and I look at 6, that's here. The slope of this line is going to be 1. And then the slope of the line at 5, which is here, which is also 1. The slope of this line is 1. So this is going to be 4 plus 0, which is just 4.